Demonstration number 1 is run in the wind testbed. So in the demonstration driver, I'm going to hit the demonstration number 1 tab over here, and I will be redirected to the wind DC premises. So as you can see here, I have been notified that connection to the trial site of wind was successful, and that the currently active policy for this data center is to optimize performance. We have a set of related constraints related to avoid VM standbys and do not stop them, also preserve their performance, and do not accept cross-DC inbound migrations, which also means that we should not allow for outbound cross-DC migrations. So simultaneously to the demonstration driver, we have connected to the actual Dolphin installation in Wind. So this is the Dolphin ECOPDB broker module. We can have a look at the virtual machines that are currently hosted in the experimental testbed that host the Dolphin installation. We have currently 6 VMs. When clicking on a UUID, for example, of a VM, we can have a look at its flavor, when it was first instantiated, and which node it runs on. You can also have a look at the related logged actions, and also a look at the latest measurements that are caught through the Dolphin monitoring system. When clicking on the server name, we can have several details about the server where this particular VM was hosted. So indicatively, we can see that the previous VM was hosted in node 3, which is a 16-core one with 2.4 GHz of maximum frequency, 64 GB of RAM, and about 8 TB of HDD. What we can also check is the minimum and maximum watt per core, the virtual machines currently hosted, several related actions. We can see that it was shut down and waken up at some point in the past. And we can also have a look at the latest measurements that pertain to the server. We can also see that the server is located in rack 1, which when I click we can see the relevant details. So in this page we can see that rack 1, which is the only one available in the Wind data center provided to the Dolphin, 3 physical servers have been hosted, node 3, node 2 and node 4. And we can also have a look at the latest measurements related to this rack. Heading on to the measurements, from this UI over here, we can have a look, for example, at the power consumption of the rack. For example, during the last 2 hours. As you can see, this one is pretty steady except for 2 cases where we ran some tests prior to this recording. We can also have, let's say, a look at the CPU utilization of certain VMs. Their memory usage. We can also have several other information related to disk writes, read writes, etc. Heading on to the metric sections, for example about PUE, we can see that the value is always 1, and this is because we are not having any cooling mechanism measurements in order to non-IT in general, to be more accurate, measurements about energy consumption. So normally all IT consumption consists the total IT consumption, hence the PU is 1. Heading on to the logging, you can see all the actions that have been issued to the policy actuator and logged inside the ECOP-DB. Heading on now to normal test execution, we can see that currently we have 2 VMs running on node 3, namely that one and that one. We have 2 VMs running on node 4 and 2 VMs running on node 2. Now, granted that all servers are identical, a single server could handle all traffic. So what we would expect from the optimization plan is to consolidate all VMs inside a single server. Before moving on to the actual test, let's have a look also at the DOLFIN services dashboard provided by Supervisor. Supervisor is an integration software that we have used during the integration activities of DOLFIN and that we have found very useful and very effective in handling custom services. For example, we can have a look at the logs of the ECOP-DB, or for example the optimization component of the optimizer, or again the actuator. Heading on to the actual demonstration, we can see that the active policy for Wind is to optimize performance, as we said. And we can also check that this is true through the dedicated optimizer dashboard. Particularly when selecting policies, we can see which is the active policy that is governing proper DC operation. So what I'm going to do now is to hit on this button to set the policy to optimize energy efficiency. Then this demonstration driver will communicate via API REST calls with the optimizer and set the new policy to optimize against energy efficiency. So as we can see here, the active DC policy has changed. Something that we can also cross-check by clicking on the available policies of the DOLFIN optimizer, and as you can see here, the active optimization policy has changed to optimizing against energy efficiency. Now, assuming that the DC operator, or else the administrator, I can hit on the request tab and ask for a new optimization request. If I click on the newly generated ID, we can see that the status of the optimizer has been updated to working and that we have no actual result about the optimization plan generated. Now moving on to the loading facility, we can see here that the new optimization process has started with an ID of 9. I mean the request ID is 9. What is being done right now is that the optimizer is querying the ECOP-DB broker about the latest measurements of the VMs. Then based on that information, it will calculate the energy consumption of each VM, hence the overall energy consumption. Then it will devise a plan to minimize the overall energy consumption based on a multiple knapsack solving algorithm. Now, as I was talking, you could see that the optimizer took information about the available prices, so it calculated an estimated energy over the next hour. The cost would be that one because the price was 1. Then right after these printings here, it performed the optimization calculation, and it identified that we can have 61.34% of energy savings, supposing that this request is first approved by the policymaker, then implemented by the policy actuator. Now if I check at the policy actuator logs over here, you can see that a request for migrating several VMs has been arrived and that it has been readily handled. Right now we are in the middle of migrating VMs, so I guess that if I go to the ACOP-DB and refresh, okay, correct, we can see that now all the VMs have been migrated to node 2. Next we can see that a request to hibernate the servers has arrived. Node 4 was successfully hibernated, whereas node 3 did not because of a permission error. And this was something that we expected. Heading on to the optimizer, what we would expect from the optimization plan that was generated as a response to request number 9 would be to migrate the 4 VMs to node 2 and hibernate the other 2 servers, which is exactly what happened here. Now heading on to the ACOP-DB, let's go and check the actual power consumption after the application of the optimization plan. So if we wait a bit, we will see that the overall energy consumption will drop. As you can see here, we have readily a new measurement indicating that the energy consumption has dropped. Indicating that the test was successful.